Hi Biobombs, I'm Anvita, and today we're going to be going over Pre-algebra Units 4 through 8. Today's topics include arithmetic sequences, geometric sequences, how to simplify expressions, and how to solve equations. So let's get started with arithmetic sequences. Arithmetic sequences are generally expressed with the formula a of n equals a of 1 plus the quantity of n minus 1 times d, where a of n is the nth term, a of 1 is the first term, and d is the common difference. Another way to express this formula is a of n equals d times n plus a of 0, where you use your 0th term as your base term. Let's try to do some example problems on arithmetic sequences. The first topic we will tackle is the common difference. In our example, our sequence has 3 terms where the first, second, and third term are 14.4, 20.4, and 26.4. To find the common difference, take the second term and subtract the first term from it to get your answer. So in our case, 20.4 minus 14.4 is 6. To double check our answer, we know that 26.4 minus 20.4 is also 6. The next topic we will try to do a practice problem on is trying to find the first term. If our equation is given to us in the format of a of n equals dn plus a of 0, then we plug in n equals 1 into the equation to find the first term. In our example, a of n equals 25 minus 10n, and if you plug in n equals 1, then you can calculate the expression to come to the answer that a of 1 equals 15. The final topic we will work on for arithmetic sequences is trying to find the formula of a sequence. In our example, if we are given that a of 1 equals 25 and the common difference is 100, then we can plug these numbers into the formula where a of n equals a of 1 plus the quantity of n minus 1 times d, allowing us to get the final answer that a of n equals 25 plus the quantity of n minus 1 times 100. Now let's move on to geometric sequences. Geometric sequences are generally expressed with the formula a of n equals a of 1 times r to the power of the quantity of n minus 1, where a of n is the nth term, a of 1 is the first term, and r is the common ratio. The common ratio has the same purpose as the common difference, but rather in geometric sequences, it is the common multiplier. Another way to express this equation is with the formula a of n equals a of 0 times r to the power of n, where a of 0 is now the base term. Let's try to do some practice problems with geometric sequences. The first topic that we will try to tackle is to find the common ratio. In our example, the first term is 3, the second term is 18, and the third term is 108. To find the common ratio, take the second term and divide by the first term. So we would do 18 divided by 3 equals 6 to find that our common ratio in this example is 6. Now let's try to find the first term. If we are given a formula where a of n equals 2.0 times 5.0 to the power of the quantity of n minus 1, to find the first term, it is simply the coefficient that you're multiplying 5.0 to the power of the quantity of n minus 1 by. So we know that a of 1 equals to 2.0. But if we are given an example where a of n equals 2.0 times 5.0 to the power of n, we need to plug in that n equals 1 to find our first term. So if we do 2.0 times 5.0 to the power of 1, we know that a of 1 equals 10. The third topic we will try to tackle is to find the formula of a geometric sequence. If we are given that a of 1 equals 4.1 and the common ratio is 4.0, we know that the expression can be written as a of n equals a of 1 times r to the power of the quantity of n minus 1, so our final answer is a of 1 equals 4.1 times 4.0 to the power of the quantity of n minus 1. Let's move on to simplifying expressions, and here we will also do some examples. When simplifying expressions, you are generally trying to go from a complex expression to a simple expression, and this generally involves less terms being produced, but there are some exceptions. Let's try a practice problem. For example, if you have 7 times the quantity of 5n minus 1 minus 2n, Then you can use the distributive property to rewrite the expression as 35n minus 7 minus 2n, and then collect like terms to simplify it down to 33n minus 7. Another example we have is negative 3 minus 8n times the quantity of 4 plus 7. Here, we can combine the two terms inside the parentheses to rewrite the expression as negative 3 minus 8n times 11, and we can simplify it down to negative 3 minus 88n. Since there are no like terms to combine, this is the simplest form of the expression we can produce. Let's switch gears a little bit and move on to equations. When solving an equation, there are two parts of the equation that you always need to remember: the constants, which are the numbers without any variable attached to them, and the variables, which you are trying to find. The format of an equation is generally two expressions combined with an equals to sign. For example, 4 plus 3x equals 7. The point of solving an equation is to satisfy the conditions that are presented by the equation. Let's try to do some practice problems. The first one that we will try to solve is 20x plus 7 equals 5x plus 65. One thing to remember when you solve an equation is to do the same operation to both sides of the equation. So, the first thing that we will do is to subtract 7 from both sides. So now we can rewrite the expression as 20x plus 7 minus 7 equals 5x plus 65 minus 7. Now it can be rewritten in a simpler manner as 20x equals 5x plus 58. Now we can subtract 5x from both sides of the equation and say 20x minus 5x equals 5x minus 5x plus 58. Now we can say that 15x equals 58, and if we divide both sides by 15, we know that x equals to 58 over 15. Let's move on to a second example. In our example, we have 8 plus x equals 5x minus 4 times the quantity of x plus 9. The first thing we will do here is follow the order of operations by expanding. We can rewrite the expression as 8 plus x equals 5x minus 4x minus 36 after we apply the distributive property. Now we can collect like terms on both sides of the equation and rewrite it in a simpler manner as 8 plus x equals x minus 36. If we subtract x from both sides, we can now say that 8 plus x minus x equals x minus x minus 36. This leaves us with 8 equals negative 36, and since these two values are not equal, this equation has no solution. This is a special case where the equation has no definite answer because the variables cancel out. Thanks for watching. Stay tuned for more math videos. Thank you.